mean, I personally don't feel the need to wait.
Okay, sounds good.
If somebody else does. I just like to get through these things.
Sounds good. Okay, well, I mean, I think I was the one who was basically trying to get more info about this project so that I can actually be helpful and actually contribute. I have been looking through the write-up, which is definitely helpful. And I guess what I'm trying to figure out is, you know, when I use Pack today, it just feels like I'm running, you know, it just runs Docker and it runs, you know, Docker commands, et cetera. You know, like what we're talking about with multi-arch, you know, it seems like we're either going to fundamentally shift how you're doing that, or, you know, like I want to get kind of like more information about how things are done. I have looked a little bit at the code base, but it's a little overwhelming when you don't really know where to start. So is my assumption right? Like you're just using a Docker API of some sort to talk to create, you know, run images, to create images, run images, whatever. Like I'm really kind of like looking for information, and then as we go, I can ask questions, but you know, I'm just trying to like start the conversation. And obviously, if you guys want to have the conversation go in a different direction, that's fine. But really, I'm just all ears right now, and I just want to learn.
So, there are people here who know Pack better than I do, far better than I do. But I feel like I'm possibly a nice halfway house between having not touched it too much before and you know, Jesse or Natalie level of guru. So Pack will set up everything such that it then at some stage can effectively hand over responsibility of doing things to lifecycle. So what Pack does is it will pull down images from various sources that it might need. And what it will do is it will run those images. Pack itself doesn't ever create an image. It hands over the responsibility of creating an image to something like Lifecycle, which creates the image on a container. And then Pack, and again, Natalie will correct me if I'm wrong here, once the image is created, Pack will push that image to wherever the end user wants to push it to, whether it's the local Docker daemon, which is the default for a lot of people, or it can push it straight to a registry, skipping the local Docker daemon.
Okay, that makes sense.
Natalie, I think you're muted or something. Couldn't hear you.
Can you hear me now?
There we go.
Okay. I wonder if maybe like pulling up a Miro board or something would be helpful. First of all, I want to say this is super valuable because we are all like, especially those of us who worked on the project for a while, like totally unaware of like the blind spots that exist in, you know, our current kind of set of materials that is out there to explain the project. So this is really, really super useful on many levels. I'm just going to pull up a Miro board because I can recall having a conversation with like some other members of, you know, our team at VMware who are coming up to speed. And shame on us for not putting this stuff out into the open source for other people to find. But I'm just going to pull up a new board in Miro, and maybe I can kind of illustrate what Aiden just talked about. Miro is so slow. I'm gonna
to kind of just chat a little bit about how I understand it works, which could also be wrong, and I'm sure my expectations will be reset by Natalie here shortly. But yeah, Pack for the most part runs containers, and it happens to be on Docker. There's not like a particular, you know, you can run Podman, for instance, so it's against that shared sort of like container API. So you could run a Podman installation instead of Docker, and then it spins up those containers. In this case, for like if you're building an image, it spins up the builder container and then basically lets Lifecycle do its thing. And then I think Pack also uses that same container API to actually package the builders as well, right? So if you do like a Pack create builder, I think it actually executes the Docker file against whatever container runtime you're running, if I'm not mistaken.
Okay. Yeah. I mean, this is all like definitely refreshing my memory because I remember reading a lot of this stuff, but seeing this visually is nice. So I appreciate this.
I'm just putting a note here, yeah, that when we're talking about how Pack uses the daemon, like it's useful to distinguish between the build, like the actual build, and then the creation of the builder, right? So when we're talking about here is like Pack build, right? Versus like Pack builder create, right? And like just in this diagram, these squares here are sort of running containers that are booted from the builder image, and Pack is using its Docker daemon, or the thing that it has access to that satisfies the daemon interface, which could be Podman or whatever, to create these containers.
Okay, let me ask a question. So like whenever I've run Pack, I notice that a container starts, and I think it's running lifecycle. And then I can go in there and see that there's a process running. And then when a build pack runs, I can go in and see there's like, I created a build pack that just sleeps for 6,000 seconds. And then I go in, I see it's running. So like these individual components, analyzer, detector, restore, you're saying those are containers and not individual processes inside that main container that starts?
No, I apologize. The analyzer is the process in the container.
All right, got you.
But they can be separate containers, right? So if you've ever seen anyone talk about trusted builders and untrusted builders,
Yep.
that's going to determine how many containers Pack spins up during its Pack build process. Because the idea of an untrusted container is that for the ones that have like registry credentials, they run like analyzer and exporter, just as give an example, there's others. Those run directly on the builder image, where like detector and builder, since it's going to have your app code and everything, those run, or actually I think it's the reverse, like those run on the image, and then analyzer and exporter run on like basically lifecycle scratch images that have just lifecycle on there, so that if you don't trust the builder, it doesn't have a chance to like slurp up your like registry credentials, for instance. So there's like a security barrier that an untrusted builder will actually spin up more containers to avoid giving the untrusted builder credentials that it doesn't need to do its job.
Okay. Yeah, I think I generally use untrusted builders when I do my stuff. Okay, I'm happy to like ask questions, but if people want to drive the conversation a certain way, just feel free to do that. But if no one has any specific things they want to talk about, then I'll just speak. So please interrupt me if you have something to say. Okay, cool. So, you know, when I've used this, I like thinking about multi-arch, you know, like, all right, so my experience with multi-arch is you either building it on one architecture or another. Like Aidan said in his presentation, you're either on ARM and you build for ARM, or you're on x86 and you build for x86, or you use emulation. I have a lot of experience with emulation and with BuildX. And so, you know, in there, you're just running commands inside of a Docker file, essentially, but on the emulated environment. So then, you know, thinking about this, you're running containers. So how do you run a container inside a container that's being emulated? You know, like how do you guys want to deal with this? You know, I wanted to get your input. You know, it's like, I'm like, do we need to run Docker inside Docker inside Docker inside an emulated environment? You know, like how do you foresee that kind of like situation being approached, or do we not want to really talk about that yet?
I think there's a pre-step here. And
Yeah.
again, jump in, people, if I'm wrong. Right now, Pack can't access. If you want to do a Pack build on ARM, you need to package up a builder, and you need to give it a different tag than your AMD 64 builder. So your AMD 64 builder and your ARM builder effectively end up being two separate tags in a registry. What I can't do is Pack build and have Pack look at a single tag in the registry and pull out the ARM version of that builder from that tag and start running the build.
Let me ask a question.
Yeah.
Why can't we just have one tag that's a multi-arch image so that when you're pulling for whatever arch, you're just getting the right one? Is that not possible?
That's what I would like to have. Well, that's what I would see would be the pre-step that we could build, that we could use a multi-arch image, pull out the image that we want. But right now, it doesn't understand multi-arch images. So you end up having to package your builder as one tag for AMD 64 and package your builder as another tag for ARM 64. Now,
Yeah, I don't think there's any technical limitation there, but I do think there's some holes there that we have to think about, like, because obviously anyone who's using Pack build on an ARM machine today, the Pack build is pulling the AMD 64 version of the builder. So as soon as we introduce multi-art, like, we will have to, like, at least give everyone a heads up that, as soon as, if you happen to have a image list with an ARM version there, then it would suddenly start pulling and trying to execute with that.
Maybe it would make sense. And like, this is like maybe taking us off in a different direction, but I was going to suggest that we just sort of step back and, like, we've sort of illustrated, like, this is what happens under the hood when you do a Pack build, but maybe just because we're talking about builders, we could take a step and say, all right, this is what happens when you do Pack builder create. Because I actually think that's like sort of digging a little bit, like, in the end, we want to do all the things, right? We want all the things to work. We want the cross-platform thing to just be seamless and, like, just give me the image on the platform that I desire and do it in the, like, most efficient way, right? But if we're just sort of like, okay, we're on step like 0 of 100, right? Like, what are some of the steps we need to pass through on the way to getting to that, like, seamless, flexible experience? Like, the first thing that we really need is just like an easy way to get multi-arch build inputs, right? And so, like, that kind of brings me to, like, the Pack builder create, which I'll share this link, by the way, if anybody wants to. I'll just move it over here, because I think that and actually, even before we go to Pack builder create, it might be useful to just talk about Pack build pack package, because that.
Yeah, I was about to say, I was going to suggest that we should talk about how build packs are packaged, because they're also OCI artifacts, or can be.
I don't really know the best way to illustrate this visually, but let's try. So you have your like, build pack directory, right? And that contains your bin, and that contains a build, and that contains a detect, right? Something like that. And in addition, you have a build pack toml, right? And today, if we go to our samples repo, like, let's just go hello world, right? Build pack toml, it doesn't really say anything about, like, which architecture this build pack is supposed to work with. So you're like, all right, well, I guess this stack is, like Linux AMD 64, but who knows, right? Like, right. So that is before we get to a world where like build packs are flexible. We have this RFC, the remove stacks RFC, which should really be called remove stacks and replace it with more useful information, which is here. And I don't actually think that this contains, yeah. So this is kind of showing you like in the future, instead of this TOML schema, like imagine like this gets deleted and this gets inserted, right? So you say like, okay, I don't know why this is duplicated, but
There's different versions. Yeah.
Versions. But it's like this build pack can work on Linux x86 and Linux ARM, right? So let's just grab that and I'll put it back in the other place on the Miro. Right, so we can imagine like our build pack TOML now contains this information. Does this all seem like useful and relevant to talk about? Like, I just don't want to make us, go down a rabbit hole. But anyway, so the idea is let's just say like today we make no changes to the way build pack package works, right? Like just kind of ignore this for the time being. What we do is you run this command on your host and we look and we say, oh, you're on a Linux, x86 host. We'll make you a Linux x86 build pack package. But that's inflexible, right? And so that's what all of this one is about here. Oh gosh. Yeah, this pack issue. I didn't really show like what we do, but basically just to complete the picture, pack will like slurp up this directory and it will create a tar file. I'm making this. It will create like a tar, right? And it will also create like metadata. And it'll package those things up into, because we love the OCI spec, it'll make it an OCI image, right? And then pack will upload it either to your registry or your daemon. I'll just put that there. So pack doesn't make application images, but it does make OCI images to create the build input.
Sorry, Natalie, what do we call this image?
The build pack package. We used to call them build packages, and then we were like, that's confusing. But yeah, it's the build pack package.
Yeah, and these are not runnable, right? These are just basically a tar in OCI.
Yeah, there's no basic.
I think it's like one layer, right? It's like Scratch with one layer or something, maybe two. I don't remember, but it's pretty small.
Yeah.
These are the things that are the parameters to -- build pack, though. When you run pack, so they're not runnable themselves, but they can be passed to pack in the -- build pack flag.
Yeah.
To be used.
Yep. Yeah, either to a registry or one that maybe exists in your daemon, and then also the tar itself, right? Like you can just give it. I think you can just give it the actual tar that it spits out if you did it that way. Because don't they come out as .cnb or something? Isn't that right?
Yeah. This like, oh yeah. So another destination could be just your file system. And then in that case, you'll have a .cnb extension.
So right now, for user perspective and the guys that are creating this Buildpack package, they require us to have a host for the different OS and architectures that they want to provide this Buildpack, right?
Yeah.
Yes.
And what's also an issue, Juan, is you generate a single build pack. I call it Juan colon AMD 64. Then I generate another build OCI artifact, would be Juan colon ARM 64. Build packs or pack has no idea of merging those two into a single multi-arch tag. Docker BuildX has some tooling, I believe, to take those two things and turn them into a multi-arch image. And I believe Crane also has stuff in there that will allow it to do that. But that's as deep as I've gone with Joker.
Yeah. Oh, sorry, go ahead.
No, you go ahead. Yep.
I was just going to volunteer that the process of merging it into one manifest list, like, it's clunky, but it's not impossible, right? It requires, the user to download an extra tool and run an extra command. Like, you can do it. It's not a great experience, but you can do it. I think the real value add is like, I don't want to have to get an ARM machine just to make an ARM, build package, right? Because really, what makes it ARM, right? It's the metadata, right? And like, you don't need an ARM machine for that. Just write a different, write a different string value into your config. And so, like, I think making Pack flexible enough to create different flavors of each of these build packages, like on the same host, is going to be a big win, right? And then, the next step of making it seamless of like, oh, I see in your targets file, you can actually support these different, maybe there's a whole bunch of different OS and architecture combinations here. I'm just going to go ahead and make a manifest list with like, all the supported combinations as child images.
Is it that simple, Natalie? Because in some cases, and I think in a bunch of cases, the build package would be, the tarball would have ARM specific binaries in it. So if your build and detect were sourced from, Go source code or from C++ source code in a horrible universe, your tar.gz file would have an ARM executable, Linux ELF64 ARM executable.
That I think that is, that's an interesting question, because that's sort of assuming, like, right now when you look at your build pack, like, we're just assuming that these binaries, like whatever you put here, is gonna work in whatever you put here, like on all of them, right? I think what you're talking about is like, maybe instead of just these two, like I have a whole bunch of binaries like in this bin, and then you have to kind of find the right one for the environment you're in, which
you're almost going to have like, if you wrote it in bash, that might be true, right? Like if it was just a bash build pack, like it might just work because that's just the way that it's there. But yeah, if it's Go or Rust or something and you're building it only for AMD 64, then it's going to be in the wrong format if you try to run it later on ARM.
Yeah, I mean, this is like a very helpful discussion, because when I did my first contribution to Paketo, I could see that they're compiling everything, and I was like, it's going to be complicated if they have to change how they do stuff. But just going back to BuildX, again, I've got some experience with BuildX, and when you use that tool, you get whatever architecture you're running the tool on as your default. So I think that pattern seems like fairly accepted everywhere at this point. If you're running Docker on ARM and you do anything, you're getting ARM, and that's fine. So it almost seems like we as in if you're going to kind of like do any multi-arch stuff, that pattern seems like, I'm not trying to say we need to use BuildX, but a lot of the patterns they've established have been widely used everywhere, and it's probably easier for us to just follow them for end users. Peace of mind. They don't have to go learn some new thing. They're like, oh, I've seen this before, dash platform, whatever.
Yeah.
And then the other part is, yeah, I mean, this like compiling for multiple architectures. So basically, like what you said here is this doesn't really matter what architecture you're compiling for. Like, it's what you put into the build pack that's going to determine what you run later. Like whatever you put in bin, it will work or it won't. So it's the build pack author's responsibility to provide that, those architectures or the binaries for those architectures. So, if you're going to do the target route, like you're talking about on the bottom left there, target for different OSs and architectures, then it may just be something where you create a folder structure. And if you're populating the folder structure in a certain way, then you as a build pack author know that you're compiling for different targets. But if you just have bin, then anyone who runs this build pack, it's kind of like the expectation that if it's just a bin folder, it should run anywhere like a shell script. And if not, then you should be having the targets. So anyways, I'm just kind of like putting this stuff out here. You may have already thought about this, but just sharing.
I can see what Jesse's saying, and I wonder if there's an even more straightforward approach to this, more along the lines of what Natalie was suggesting earlier. That, and what I think you're getting at, Jericho, is, can I run build pack package on x86 64 and kick out an x86 64 build pack? And can I run build pack package and kick it on ARM and kick out an appropriately tagged or metadated ARM64 build pack? And then we could use Frame or Docker BuildX or whatever to turn those two into a multi-architecture build pack.
So yes and no. I think that this process should have nothing to do with architecture, because essentially all you're doing is copying files into a tar file. That's what I got from all of this. Am I wrong about that?
Yeah, because the actual build of the build pack is on the build pack author, right? Like, we don't know how they build the actual bits inside the build pack.
So if that's the case, then like every build pack is architecture agnostic. And then whenever you're using them, you're just downloading a tar file, untarring it, and then running it somewhere. So it's really up to the author. And that's what I'm taking away, but go ahead.
It's up to the author. And again, I'm just trying to, my brain is slower than most people. So it's up to the author.
Here.
But if I write my build pack in Go, and like Jesse says, it's up to me to produce some output binaries. But I may only provide those output binaries for Solaris on Spark, in which case my build binary and my detect binary are not architecture independent.
Yeah.
And so I think one question is, how do we allow or enable build pack authors to provide metadata for their build packs so that they can, their end users can use appropriate build packs for their architecture? And the second one is what's the creation process for a multi-architecture build pack? And for the second part of that, I'd be very happy with Natalie's suggestion of let's just build pack, just use some magical third-party tool or whatever it is to take these OCI images and package them all into a multi-architecture OCI image.
I think that's maybe why Ryan was interested in being part of this discussion, right? Because they have so many build packs that they maintain.
Yeah.
And I think like what what has been proposed, I guess, as part of this RFC, and you know what we're planning to implement is like, hey, if you're writing Go Buildpacks, right, you're gonna have to have a different Buildpack directory, right? You're gonna have to have two Buildpack directories, one for ARM and one for AMD64, right? Because
Not necessarily. I don't think. And I think this just depends on at what stage you do the packaging these things into into an image. That, you know, if I kick out from I've got my Rust process which produces a build for ARM and a build for x86-64. That could be packaged individually into OCI images, an x86 image and an ARM image. And then we could merge the two images into a multi-architecture image.
yeah,
Yeah.
you could do that,
Yeah.
but you'd still need a separate this would be duplicated, right? Because if those binaries aren't shared, then like the whole thing needs to be copied over, right?
I think the multi-architecture manifest would have them as two separate layers then. So they don't need to be on the same layer.
Correct. Yeah, they'd be on different layers.
Yeah. So if we think about this in like a end user perspective, like a Buildpack author, I think what we're talking about is like a GitHub action workflow that would have build AMD, build x86, and then funneling into a combine with Crane, publish those together, right? So you'd have two independent Buildpack package commands, pass using the platform, different machines, right? x86 for the first one and AMD 64 for the, or whatever, ARM 64. And then it would be the same Rust code. All right. Just different build targets through like the workflow configuration. That's what I'm seeing as like a first step we could take instead of making Pack do both at the same time.
I think what we're talking about for the mentoring program, right, is the part that you mentioned, Jesse, like, oh, but you'll have to use different machines, right? I guess you'd have to use different machines. Like if you're using Go, right, you can cross compile, right? And if we do this thing in this pack image, provide the desired platform when creating packages, then you don't need different machines, right? Because you can just put the desired platform in at each step of the process.
You'd still have to run compile twice, right? You wouldn't have to have two machines, but you'd have to run compile twice with different compile flags. And so it kind of depends on what our goal is here, right? But yeah.
When you say compile tools, we're talking about like Go compile.
Yeah, exactly. Like if you're using a Go compiler or a Rust build pack, you're going to have to pass in the like architecture to that process, which is sort of outside the purview of pack. Like it's expecting all your bits to already be on disk before it starts packaging it.
Right.
These are already executables by the time pack sees it. So we would basically be like duplicating this whole thing. And you'd get two registry images at the end. And you combine them into a manifest list using another tool for the time being, right? But I think the idea that the big win in making the platform, in basically adding this thing, platform, right, is that you only need one worker now, right? And like as someone who's really struggled with setting up an ARM worker that falls over every like couple days, like that's a huge win, right? Like,
Yay! Ryan is here.
And as a proof of concept of something like that, my understanding is that Docker's BuildX already has QEMU built in, that when you pass the platform down to say, run this container, please, or take this image, run it as a container, you can already tell Docker BuildX, run this container on ARM64. So it's already using QEMU down at that level.
100%. And BuildKit has APIs for you to just pass that platform straight into the Docker build system. So you can just say, we use this for building ARM stacks. So like we don't have like an ARM runner or ARM VM somewhere. We just run on an x86 runner, like a GitHub runner, and we just say like, please build me this stack, but I want you to build it as ARM64. And like it's slower because it's using virtualization, but like it gets the job done.
Yep, I do the same thing too.
Yeah, and as much as we'd like to maintain independence from something like Docker BuildX and have things work on Podman and Docker, for example, as a MVP, from my perspective, that would be a pretty kick-ass thing to just make it happen. But again, I'm happy to be contradicted by lots of other people.
For the build pack package, we're not actually running a Docker build, right? Like we're
No.
just, yeah,
We're
like
not
we don't
running a
even
Docker build, but we're asking the something on the desktop, the Docker daemon or the Podman daemon, to run this image as a container for us.
I
Yeah,
don't
that's
think we run any containers, do we? For a build pack package, at least. Yeah.
no, we don't. I think so. I think the
Um,
limitation right now is like if you're saving to a registry, like the registry doesn't care what architecture you're pushing, but if you're saving it to a daemon, the daemon will reject like build pack packages that doesn't match its configuration. And so like that's why we have this like really annoying limitation right now. But we like
I missed that totally. I am really sorry for misinterpreting the past couple of minutes, but I missed that totally. That the build pack package stuff. There's no magic containers or anything involved. Yeah, sorry.
Yeah, no worries. That's why we're chatting. Yeah.
But I get the impression that the moment you import it into the daemon, it's like the daemon just picks whichever happens to be the image that matches its architecture, and the other image just kind of falls on the floor and you lose it. So like for us, when we're building stacks, like we export to like an OCI archive format on the file system, because that's the only way you can have like all of it together as a thing. And then you can like push to a registry. You can, push it up to a registry, great. And the registry will treat it as one thing, but the daemon doesn't. The daemon only looks at like its own platform specific image.
How do you get so you said you export it to like a format on disk. So is that like OCI layout format? Or what format are you exporting to?
Yeah, so it is. It's just an OCI format. We use the GGCR library to just basically take the two images that come out of the Docker build, and then we put a index over the top of that basically says this image is this platform, this other image is this other platform, and then we just tar that, and like that's your OCI.
And then what do you do to load it into the daemon if that's your next step instead of pushing to a registry?
We haven't been loading it into a daemon, but I think you can load that. I'm not sure. I think you can do like a Docker import or a Docker load. I forget which command is which every time, but I think you can do that.
Yeah, now you can Docker like load a tar, but I wasn't sure if you could do an OCI layout.
I know there's definitely like some Scopio translation command you could run.
Scopio can do that with a copy, or you can do that also with a GGCR library. There have some daemon sync and target, so they can also do that. I don't know if it's good performance.
Yeah.
But you can.
I don't actually know how useful it is to load a build pack package into the daemon anyway. Like I don't know how many folks use that. Like in our case, we publish straight to like the registry or like a CNB file, I think, and put it on a builder. Like, but I don't know.
Someone that is just playing around with the tool locally, probably. Like
I mean,
they have the samples files, and probably they do build package and try to put it into the daemon to play around with it.
But for some of the later samples and examples, the docs that Natalie's just written, we're using registry v2 locally. Does that change the picture then? Does that make things easier?
Like if we want to remove the ability to save to the daemon.
Or yeah, just support workflows, plan for the future and support workflows that are OCI compliant only, because that seems to be the direction of travel for, let's call them desktop daemons anyway.
Yeah, the daemon is just the source of all our problems, honestly. I think like if something doesn't work for the daemon, we just say like, well,
Yeah, it would be easy enough to be like the multiple platforms are not supported on the daemon. Like, go to a registry and pull it back down. Sorry, it's fine. I don't think that's a huge like blocker, especially not for the summer. Like that's not a thing.
Ryan, do you want to speak a little bit about like what, because we kind of went through what we see as sort of the lowest hanging fruit for this multi-arch stuff, but is there anything that you would like to see, as a maintainer of lots and lots of build packs?
I mean, for us, the only way that it seemed reasonable for us to go about trying to do this was kind of just like from the lowest levels up. And so for us, the first target obviously was like being able to build stacks that are like multi-arch stacks. And it's like, okay, so we have a capability. We haven't built any ARM stacks that we publish, but we have a capability to do it. And we're going to be looking at ARM stacks really shortly to like actually start to publish them. And then the next layer above that is like, how do you get build packs that can run on those stacks? So like, this makes a lot of sense that you would approach like a build pack. The step after that is going to be obviously builders, where you're taking the stacks and the build packs and stitching them together, because folks are going to want to be able to say like, build my app with this builder. I don't really care what, architecture. I shouldn't have to say what architecture. I shouldn't have to add a tag that says the architecture. So that would be the next step. And I think once you get to that, that's everything. Unless I'm missing something here. I think there's like this whole other open question of like, I saw people bring up things like, I want to be able to say pack build and have the output be a multi-arch image, where you're, I don't know, specifying multiple platforms and then it's running builds maybe in parallel and stitching them together and then coming out on the other side. That's like, much more complicated, but it assumes you already have all this stuff, right? In order to like actually have that multi-arch build, you probably need multi-arch stacks and build packs and builders. So I don't know, the figuring out how to do multi-arch build packs seems like the logical first step for CNBs.
And do you work on maintaining a bunch of build packs? Like, do you deal with like the CI/CD delivery of build packs today? Like, are you fairly familiar with build pack package?
Yeah, sure.
Okay. I guess I can guess which one you're going to prefer, but would you prefer like a GitHub action, like per build pack? Like if you build them in Rust or Go, let's say you build them in Go, you're going to have to pass in the architecture when you do the actual Go compilation. Is it a blocker to do 2 build pack packages back to back after you've built it independently for each architecture? Passing in platform, ARM64 and then x86 for the other one, and then doing something like Crane to stitch a manifest together? Or or like a build pack package for platform, like both at the same time, and have like a file system structure that has like, bin/target/AMD 64 or ARM 64?
I mean, I think I'm always going to lean towards the convenience. That's like, I have less stuff to do and less stuff to stitch together. But like, I get one of them maybe easier for y'all to achieve and get us to a solution that's usable faster. So, I understand a trade-off between them. I think we'd be fine with the, kind of less all-in-one solution.
Yeah,
Like,
because I
it
mean, it won't
doesn't sound
always be
terrible.
possible to cross compile, right? Like, so for some users, like obviously you won't be able to, depending on what language you chose to build your build packs in, you might not be able to cross compile between the two architectures at all. And I guess not thinking too hard about it because I haven't actually built a Windows build pack, but some post scenario stitching a Windows to that manifest list seems like something you might have to get into anyway if you support the same build pack across all those different architectures.
I mean, our stuff already includes like a fair amount of pre-processing before we actually get to the point where we call, pack build pack package. Mostly because it's like all of the build packs are written in Go, so we've got to like actually compile all the bits, and then we have a bunch of other files that are in the directory structure that were like, the working directory of where the command is executing. And so we like have in our build pack toml some metadata that basically says like, only pick these files. So it's like, we compile the executables, and then we basically copy those files out into a different directory, a temporary directory, and then we tar that entire thing. And then we basically say, pack build pack package here, this tarball over here, that's the build pack. So that we end up with a build pack that's really only got just the bits in it that we care about. So like there's already work that's happening on the front end. So it's like not the worst thing ever if there's like a little bit of extra work on the back end as well.
Thanks for that. You did talk earlier about doing a pack build and specifying a builder and the user not having to think about what platform it is. Obviously, there's going to be differences between builders and what build packs they support. I don't know if we've talked about like what does the end user experience look like if today you're running pack build on an M1, so you're locally testing Piketto's version of this build pack on ARM, and then you make a GitHub action, which are by default are not ARM, and then you're publishing it to then be using in production, which is on an x86 host. Is that just sort of, are we just trying to say that's sort of, I guess, the expected flow? And if you're running x86 in the cloud versus ARM locally?
Yeah, for the most part. We almost never have a situation where someone like compiles something on their workstation and that somehow ends up in like a production distribution, because all that stuff is just like the only way to get something in like a distribution is like committed to CI, and like GitHub builds it for you on x86. The question of there being like differences in like, oh, this test passed when I ran it on my local workstation, but like this doesn't pass in CI because there's like some architecture issue. We haven't seen that yet, but like that's not to say that that won't happen. The one thing that's nice is I do think it's possible to just run like the M1 stuff in some sort of emulation mode that basically says like I actually want to run this as x86. So like,
so
I don't
keeping
know,
the
if you
users in the
ever,
dark is kind of like the preferred path until they suddenly find a difference. Is that kind of what you're thinking right now, at least?
yeah.
So I was going
As far as like a user goes, I mean, Jericho can probably speak to this. So I'm probably just stomping on your comment here, but I think the user's experience is probably not that great because like what they're having to do when they use the build pack, because the build pack is x86, is like everything always is running in emulation. And so it's like always slow.
Yeah, I was just going to say something along those lines. Not many users want to test things locally, but when you're trying to convince someone to use build packs, they're going to want to test things locally before they decide I'm going to use this for all of my apps going forward. And if the experience is, well, yeah, you have to jump through 10 hoops before you can use this, and it's probably not going to work right because you might get some compilation error. You might get some errors. It's not really ideal. So, like in an ideal world, if a user says pack build and they build an image, it should just build it on whatever architecture they're on. similar to when you say Docker build. You know, but again, I'm not trying to make things complicated, but you know, that should, in my opinion, that should be the goal. You know, if you're on an architecture, it should just work on that architecture. And if you're trying to do something on a target architecture, then you're not, you're doing more complex stuff. And that is to be expected.
Yeah, I'm just thinking about like the local developer experience. Like when this is all said and done, we do a pack build. Because you're on an M1, it picks ARM, and then you try to push that to your Kubernetes test cluster, and it doesn't work because by default it's not ARM, and you don't even realize it because, you know, it's not something you've been thinking about because, you know, you're just trying to learn about Pack and Docker and all that sort of stuff. So just something to think about. I don't really know how to make that. I think it's an easy transition to make because if we suddenly add platform to pack build, you're like, oh, I built it for the wrong platform. It has this great dash platform, x86. And oh man, that's a lot slower, you know, and that's fine for that to be the experience. I think the default experience that you're proposing makes sense.
So I think Ryan kind of missed the part where we were saying, we were kind of like talking about pack build pack package. So is the takeaway that you're just going to say pack build pack package target architecture, and it's going to build you that, and then you have to then stitch it together with another tool. Is that like the outcome that we're coming to?
That would be my vote for a first pass. It simplifies things. It sounds like there's already pre-processing for like Buildpack authors. I think our Buildpack authors do the same thing where they're sort of like building it kind of off to the side and then tarring it up afterwards.
We sort of glossed over Pack Builder Create as kind of being the next step in the process, but you can imagine like once we have this, right, there's sort of a similar picture that we can draw of like, look in your builder TOML file and like, you know, if you have a bunch of build packages, like pull the right architecture down, right, and making your builder for a specific arch, but like having the ability to change the target arch and really not care about what the host arch is. Like that's kind of a logical extension of this one, which I would propose we do as part of the, you know, it's kind of unsatisfying if you just do this part and then like can never do a build with it, right? Because you have to do the next step of collecting it into a builder image.
Does Pack Builder Create actually run any containers, or is it similar to Pack Build Pack Package in that case?
It's similar to Pack Build Pack Package. It's like you have your builder TOML, and it's basically, it's, you know, there's a bunch of different ways you can provide build packs. They can be as a directory, they can be as an archive, you know, they could be as an image in a registry, like, you know, it's flexible. But assuming we're talking about build packs that exist in a registry, let's say, like, yeah, you would just go find the right one for the architecture that is desired, and then it packages it together into an image where, you know, each layer is a different build pack.
I guess there'd be a lot of validation up front for the defined build and run images to make sure that the manifest list has the architecture that you're talking about.
Yeah, I would think you would just fail out if any one of the inputs doesn't have a version that matches.
Because you couldn't check the mirrors, but you'll just have to assume that that's okay. And I think that's okay too.
I have a question. Like if you do build pack package, and then let's just say you allow multiple platforms, and then each platform you're specifying a directory where like that, you know, it's been compiled for that platform. Like, wouldn't it be possible to just have that one command do the manifest stuff for you all at once? You know, like wouldn't it be a cleaner experience if you're doing this to say, I want a build pack, I don't want to have to run another command later to then create my image. I want it to just be, usable right when I run this command. For Ryan, for example, like in your CI/CD, like if you're going to do some work to compile for ARM and x86, and then you just have these tar files, and then you can say target tar file x86, target tar file, ARM64, whatever. Would it be valuable to try to approach it from that perspective?
Oh, for sure.
Yeah. Are you suggesting a single pack execution in that case, or multiple with it sort of appending to the manifest list each time?
I'm saying one pack execution where you can either with a config file or with flags say, I'm going to build for these target architectures. And then when it creates the image, you're going to get that image with whatever tag you want to give it. And it will do all the work in the background to get the manifest created so that when you pull, you're getting the right architecture.
I think it's possible. Like we could do it right now. I think these config and path values are somewhat like mutually exclusive. Potentially, but like you could imagine like I can provide a list of paths, or I can provide a list of configs, or we'd have to think about the UI for that so that it's not terribly confusing. But there could be a way that you say, look, all of these things that are packaging up are actually the same, but just for different platforms. And
it also sort of makes the assumption that you can cross compile, or that you have all those bits in the same place, which I think is reasonable for most. But like in the Windows case, you're not going to be on the same runner unless you sort of like push the bits up somewhere and then have a final one that sort of does the packaging after pulling it all back down.
Yeah, that's a good point. Yeah, I see where you're going. I mean, like get it to work first, and then if possible, go for the extra icing on the top. Okay.
I think if you of us have to run like now, but this has been like really helpful for me personally, and I think we definitely made progress here. Should we just catch up on Slack about next stuff? Like hopefully we start to get some applications from mentees, and we can add more detail to the issues. But
I like it. I can share the link out. I'll just put it in the thread. I guess anybody can watch it if they want. It's nothing private here, so great. Thank you very much, everyone.
thank you.
Thank you, guys.
Ciao. Thanks a lot.